Put you back in. Put you back. Okay. So now the particle count should go down. Now down to 97, 966, 964. The next filter was taken out of a train system. It was a ceiling mounted grill. So as you can see with the pleated air filter, the half micron particle count is going down. Now down to 948, 943. So it is removing half micron particles from the air. Okay, I'll take the filter out. Particle count will go back up. So this is a clean 20 by 20 air filter. And now it's 1 inch. The particle count is going up. Now the question is, this filter was left in for a month. Could it have stayed in the unit for another month? Has the particle count or the static pressure, the energy used to move air, has changed that much? Let's find out. So now we're back up to about 1054. That's 100 out of 1,000, which is about 10%. And a new filter has about a 12% efficiency at a half micron. So now, let's put in this other filter. This filter's been in a train unit for a month. It's pretty bad. I'll show you here. This is a new filter, and this is a dirty filter. Okay. So now, it's up to 1100, and we'll put the dirty filter in. Okay? Static pressure is going up, airflow is going up, particle count. Pretty dirty. There's some particles that probably dislodge from the filter. But what I want to show you that even though this filter's been in a month, particle count will go down, and it's going down right now. It's now down to 1034, 1032, 1027, 1022. So the particle count is going down. Down to 990. So even after a month, the filter can remove half micron sized particles. As you see, the particle count dropping. Pretty neat. It's pretty neat. So I would have left the filter in. But let's check the wattage and see how much that has changed from the clean filter. So we're down to 970 on this filter. I'll leave it in, and now we'll get the static pressure. Helix, about 0.446. monitor. It's reading 0.48, and it's using 288 watts. 0.48 and 288 watts. So it's using 289. It's using 3 more watts. Larry? It's amazing. This is amazing. It's using 3 more watts. 0.49. The static pressure's changed to 0.02. This filter should have been left in longer than a month.
Yeah.
Oh man.
Wow.
We're changing the filters way too soon. And the particle count. Okay,
Still doing great. It's down to 1,000. Look at that. It's down to 1,000. 994.
Yeah, I mean it's going.
Yeah.
This is amazing.
I need to be able to show all this.
Yeah, watch. I'll take the filter. $970, $968. That's great. Isn't that neat? Oh man, that is. And the only way you can tell is by measuring. Now let me put a brand new filter in, just for that.
Yeah, you could offer that service to a customer.
Yeah.
For here, let me show you after 1 month, after 2 months, after 3 months.
Okay, I'm putting a brand new clean air filter. Let's see how much lower it goes. Oh man. Yeah.
So what happens to the watts and all? Yeah.
Yeah. Listen. Oh, isn't that neat? They're changing filters out too often. Oh, man. This is a clean filter. 0.47. 286. Oh, man. The monitor isn't that amazing. That alone could be a business. Telling them when to take out the filter and when to change it. Same time. Energy stock and change them out when they don't need them. Oh, this is beautiful. Okay, so here we are. Yeah, I'll do that service. It'll save you money on changing the filters unnecessarily, and you'll get cleaner air. Whoa! Okay, this is the brand new filter. The particle count is 975, 975, 974. So you can see 966, 970. Now I'm going to take the new filter out and put in the dirty filter so you can see that again. Unbelievable. New filter comes out. And this dirty filter goes back in. Or read the particle count. It's hanging right in there. It's hanging right in there. Isn't that amazing? I'm going to test the other filter, this other dirty filter, and we'll see. Okay, so this first dirty filter was from a train unit. The filter's been in for a month, and you can see it's 980, 81, 978.